Here's Niji. She's a super dog, and she's gonna watch our science experiment today. Yeah, or maybe not. Maybe she'll go down here. Okay. All right. Last week we did this lab, Molecules Matter, Chapter 1, Lesson 1. And what we noticed is that molecules, water molecules, are very sticky. They want to stick together. That's called surface tension. We put those drops of water onto wax paper, and what you should have noticed is that they easily come together, but they're very difficult to split apart. If you used a popsicle stick to try to split that water apart, you'll notice that it kind of wants to blob back together. This week, we are going to investigate the question, is the speed of the water molecule different in hot or cold environments? Okay, so we learned that water molecules are always moving and bumping into each other and they stay pretty close. Well, what if that water was cold? Or what if that water was hot? Does that affect the speed at which they move or their ability to come together or stay apart? Okay? So if you're doing this lab at home, all you need is hot water and cold water and food coloring. Okay, and if you don't have those, if you don't have any food coloring at home, just go ahead and watch this video and you will be able to see what it is that we're talking about in order to answer these observation questions. Okay, so I have 2 beakers of water down here, and we are going to drop a drop of blue water and a drop of yellow water into the hot, and we're also going to do the same thing into the beaker of cold water. And what we'll notice is that there'll be a difference in how quickly the water mixes. Okay, so I'm going to put this onto full screen. There we go. And I'm going to tip this down. All right, if you're doing this in lab with me, you'll get little droppers to put the food coloring in so that we don't use too much of it. But if you're doing it at home and you don't have droppers, that's totally cool. You can just use the little food coloring containers, work just like droppers, so that works just fine. Okay, if I can get this out without spilling it all over the place, that would be good. Okay, so here's the yellow, and we are also going to do blue. All right, I have an ice cube in this one to keep it cold. I'm going to take that out just so that there isn't any other variables in there. And then I am going to drop 2 drops of blue and 2 drops of yellow into this cold one first. Drop, drop, and blue. See that those drops are kind of sinking to the bottom. There's some on top, but not really mixing in this area, right? And we'll do the same thing to the hot water. 2 drops of yellow, 2 drops of blue. Let's see what happens there. We'll just give it a couple minutes to observe. What are you noticing? Sure seems like this one is turning a dark green very quickly, right? This is the hot water. And this is the cold water, where it's mixing a little bit, but those drops of dye are staying fairly separate. They're both water. And I didn't put anything in here to mix it up in either of them. So what's happening to mix the water all by itself, do you think? Very interesting. Okay, let's go back up to the lab. Okay. So it says, allow the colors to mix on their own as you watch them for a few minutes. Okay, we're gonna check back with those in just a second. It says, what did you observe? Describe what the colors look like and how they moved and mixed in the cold water. Okay, so we're talking about this one right here. How did that dye move when we dropped it in there? And how is it moving over time? Okay. Question 2, describe what the colors looked like and how they moved and mixed in the hot water. That would be this one right here. Can't really tell by this light, but it is a beautiful dark green color. And then the third question says, what does the speed of the mixing colors tell you about the speed of the molecules in the hot and cold water? And this gets at the question I had earlier about what is mixing these two things. This one is all mixed up. You can kind of tell it's green, very strange light there, but it is dark green. And this one has stayed really dark blue at the bottom, yellow in the middle. It's starting to mix a little bit. There's a little bit of a green layer right here, right down at the bottom here, but still pretty separate. Same amounts of water, same amounts of dye. So what mixed these ones and not these ones? Okay, back here. And then it says explain it. Based on your observations, fill in the blanks with the words increases or decreases. Okay, so question A says heating a substance blanks molecular motion. When I say molecular motion, I mean the molecules of water moving. Okay, so heating a substance will increase or decrease their motion. And then question B, cooling a substance will increase or decrease their motion, molecular motion. Question 5 is asking you to draw. If you can get really fancy with Google Docs and you can make circles and little motion lines over here, that's cool. If not, go ahead and just draw it on a piece of paper, take a picture and upload it with your assignment, okay? This diagram here, and we'll get used to seeing this representation of water. We're just going to use little circles and then these motion lines here. So we've got 2 motion lines showing that they're wiggling at room temperature. How will the space between these molecules change in hot water, and how will the motion lines change? Will those increase to show more motion, or will they decrease down to 1 to show less motion? Okay, and same thing over here. You're going to draw in water molecules. How close together are they in cold, or how far apart are they in cold? And then does the motion increase or decrease? And represent that with a little line here. Okay, remember this is room temperature and they're moving with 2 lines. So if you're going to show an increase in motion, you'll do 3 lines, and a decrease in motion, you'll show 1. All right, and here's this last question, and this might make you have to think for a while. So there's your warning, okay? Number 6 says, let's say you measure exactly 100 milliliters of water in a graduated cylinder. And you guys can all do that. You've shown me that. That's great. You heat the water and you notice that the volume increases to 104 milliliters. Okay, so you put in 100, you've heated the water, and now it says 104. Using what you know about the attractions between water molecules and the way heat affects molecular motion, explain why the volume of water in the cylinder increases when it is heated. That's kind of a stumper, isn't it? Well, let me show you a little video clip. See, I'm on the wrong page. Little video clip that might help you understand what I'm talking about. Okay, so this says the molecules in cold water are moving slowly and are close together. As the water is heated, the molecules move apart. or faster and are a little further apart. So I'll play this animation. You can see that here's all these water molecules constantly in motion, bumping into each other, but wanting to stay pretty close because they're sticky, right? They want to attract. And if we turn up the heat, we'll go halfway. What do you notice about the speed at which they're moving and the space between them? And if we go even hotter, what do you notice? Okay. So that is the molecules in motion lab. Again, if you do have the supplies to do this at home, I really encourage you to do that. Otherwise, if you're with me, we can do it in class. And actually, next time you do come to class, mention it if you'd like to take part in this lab and you didn't have the supplies. I'm happy to set you up either in class if we have time or put you in a win time with me and we can take care of it. Okay? I hope you are well. Talk to you soon.